I can live with being by myself in class today, I suppose, but I'll just talk to myself and work on this. Hopefully we'll get some other people checking into this class. But for those of you who are watching this class later and then turning in your work, we're going to just go ahead and start recording and be done with it. Okay, so we are into functions within MATLAB today. Let me share my screen with everybody here. So functions within MATLAB. MATLAB has many built-in functions and we're going to explore them today. Learn how to use a bunch of them and then turn you loose on working with functions yourself. And first of all, we're going to start with just some basic math functions, and then we'll move on to some more complex things, well, not necessarily more complex, but not necessarily mathematical functions, just other built-in functions by MATLAB. Of course, we've dealt with a few functions already in MATLAB. We've dealt with things like the square root function, I believe. We have the square root of a number. Take the square root of 49, for example, and plug that in and hit enter. And MATLAB knows how to take the square root. Take the square root of negative 49. And it even knows how to do that. It answers it as a complex number. And if you're not familiar with complex numbers, don't worry about it. But it answers it as a complex number, and you've got 0 plus 7 times I, which is the square root of 1. And it knows how to do that kind of math as well. So that's a good little function. But it can also work with arrays. So if we have an array, let's build an array x equals, let's do an array from 2, 4, 5, 67, and 765. For example, and I'm going to suppress the output of that using a semicolon so that it doesn't print to the screen. And then I take the square root function and I do the square root of x, then it will return an answer that has the square root of each of the elements of my array x. And I mean, you can do that with you can use that for a lot of things when you're working with arrays. Of course, you can build an array of numbers and then plug it into a formula that has a square root, and it will work as well. So there's a lot of good things to do with that. Another function that is a mathematical function is related to division. So if I take, for example, 10 and I divide by 3, then I get the answer 3.333, and of course that is a repeating number. It never ends, but MATLAB cuts it off at 4 digits in the settings that I've got here, and I've just got 3.3333. However, I can also do the math a slightly different way. I can use the rem function, which is the remainder function, and I can put in the number 10, and I can put a comma and put a 3, and then put a parentheses here and hit enter, and it gives me an answer of 1. So this actually tells me that the answer to 10 divided by 3 is 3 with a remainder of 1. I take the whole number from my previous answer, and this is my remainder. This is essentially going to tell me the remainder of that division problem if I used long division and got a remainder. That can be helpful because then the answer, the exact answer to this, of course, is going to be 10 plus 1, which is my remainder, divided by my divisor, which is 3. 10 plus 1/3, which is, or not 10 plus 1/3, sorry, it's 3 plus 1/3. 3 plus 1 divided by 3, you take the answer, the dividend of the answer 10 divided by 3, which is 3. And then you add to it the remainder divided by the dividend again, and that's your answer, 3.3333. Right? So that can be a useful thing if you want to know the remainder from a division problem. Let's see. What other mathematical functions might we want to talk about? Of course, we have our trigonometric functions like the sine, just sin. And normally we would, put in the sine of 0, for example, and you would expect to get 0 because the sine of 0 degrees is 0. But here, if I put in the sine of 360, which should also be 0, it doesn't give me 0. I didn't want sun, I wanted sine. So if I do the sine of 360, I do not get 0. And the reason for this is because MATLAB does not read angle as a default. It actually reads in the units of radians that we call them. They're a dimensionless unit. And there are 2 pi radians for every 360 degrees. So if I put in the sine 2 times pi instead of the sine of 360, it gives me a very, very small number, which is essentially 0, right? The sine of 2 times pi. And it's giving me that because of the settings in MATLAB are telling it that I want very high precision. So it's very, very close to 0. It is 0 essentially. If I do the sine of 90 degrees, which I should expect to get 1 from that, right? It does not give me 1, it gives me 0.8940 because 90 degrees is not the same as 90 degrees for the radian system. For radians, the 90 degrees is actually pi over 2. So I take pi, I divide by 2, and I'm going to get the answer 1 for the sine of pi divided by 2. So you have to just realize what kind of numbers you're allowed to enter in there. If you want to convert your angle into radians, then you're just going to take your angle, which let's say we're doing 67 degrees, and we don't know how many radians that is. So 67 degrees is my angle in degrees. Then I'm going to divide that by 360. And I'm going to multiply by 2 times pi. And that will give you your angle in radians. 67 degrees turns out to be 1.1694 radians. So if I take the sine of my answer, if I just type in answer because that's my last answer, I will get the sine of 67 degrees, which is actually 0.9205. So, that is one of the trigonometric functions. We also have the cosine. So you can take the cosine of 0, which we would expect to get 1 out, right? We have the tangent. What is the tangent of 0? Also 0 because it's the sine over the cosine, right? And we also have cosecant and secant and cotangent and arctangent and all these other functions in MATLAB that you can use. You can also use functions within functions. So for example, if I have let's say I do an array, let's call it A, and let's let A equal 2 and 4 and 6. There's my array, and I want to take the square root of the sine of x. That is perfectly fine, not x, a. That's perfectly fine, but make sure that you get your parentheses correct. The square root requires parentheses, and the sine requires parentheses. And so we've got 2 sets of parentheses, and when you put your cursor next to those parentheses, it'll show you the other parentheses that are related to them. And it'll do the same thing here. So make sure you've closed all your parentheses up, and then you can go ahead and do that math all you want. It can get complex, complicated. Let's talk about some non-mathematical MATLAB functions before we get too far into things. We're going to try to see a few more. Well, let's do some more mathematical functions. I forgot a couple here. So you notice that this answer that I've got here has 0.9536 and it also has some imaginary numbers in here, or complex numbers going on here. And you can actually take the absolute value of things. I could take the absolute value of this answer and I'll turn it all into real numbers. And that is very useful. It's particularly useful in this class when we start dealing with negative numbers. We might come up with, for example, we have an array of numbers. Let's call it B equals the array of numbers negative 45, 8, negative 32, 98. And we've got this array of numbers, and we want to take the square root of these numbers, but we don't want to get the complex. I mean, if we just take the square root of b, here you get complex numbers because of the negative numbers that are in there. If we don't want complex numbers in there, we just want to know what the square root of 45 is, we just want to erase that negative, we can actually take the absolute value, ABS, of b, and then we can actually see that it turns everything into a positive number, or to a real number. In this case, just positive numbers. So you take the absolute value of those numbers, and then you can go ahead and take the square root of that answer, and you have the square root of positive numbers, giving you real square roots. We also have another called the nth root. So if you need to take the cubed root of a number, for example, the number 27, if I take the cubed root of the 27, I do 27 comma 3, and it'll give me the cubed root, which is of course 3. And with cubed roots and fifth roots and seventh roots and all odd numbered roots, you can get the root of a negative number to be a real number. So if I take the nth root of negative 27, and I want to take the third root of it, again, this also has an answer that is distinct. If I actually type it in right, nth root. So negative 3 times negative 3 times negative 3 is negative 27, so that is the true nth root of negative 27, the true third root of negative 27. There is another way to enter in roots into MATLAB, because MATLAB does recognize exponents that are fractional exponents. So if I wanted to take the nth root of negative 27, I could put in a negative 27 here, and then I could raise that to a power that is a fraction. So if I raise it to a fraction of 1/3, that is the third root of negative 27. Let's try that out really quick. I'm going to hit return, and it doesn't give me the right answer. And that's because what it's seeing here in this code is negative 27 raised to the 1 divided by 3. And that, of course, is negative 9. What I want to do is I want to isolate each part of this answer with parentheses. I want to make sure that the negative and the 27 are all one number, so I put parentheses around it. And then I want to make sure that the 1 and the 3 are both in the exponent, so I put parentheses around that, showing that this exponent is putting the 1/3 completely into the exponent. And then if I hit return there, it will give me the right answer as long as I've done it correctly. It looks like I haven't quite done it correctly. Hold on just a second. I don't know why it's giving me a complex number, but it is. Okay, so it doesn't like it when I put the parentheses around the negative 27 for some reason. It gives me that complex number, but if I do this one and put it here, then it likes that better. It deals with that better. And that's fine. So just remember that. But that's the nth root function. We've done nth root, square root, of absolute value, exponential. Now this one confuses people. Exponential 4. Sometimes people think that this is equal, this exponential 4 is equal to like x to the 4 or something. But it's not. This is actually a number. The exponential is the natural exponential, and if we just put the exponential raised to the 1 power, it gives us a value of 2.7183, and it's actually a number that keeps repeating, it keeps going on and on forever like pi. So it's an irrational number, as we call them. But it is a natural number that comes from, it actually comes from natural growth and decay functions, and it's used a lot in science and engineering. So if you ever need to raise the natural number, which we call e, little e, if you never need to raise that to a power, that's the function used, is the exp. And of course, there is there is a function that is the inverse function of that, which we call the logarithm. So if we have log for the logarithm will take the number 27183, and it'll tell us what power we raised e to get that number, and it turns out it's equal to 1. Now, logarithms are a little confusing to students who haven't seen them before, so let me explain them a little bit using MATLAB. Exponentials are, of course, numbers that are raised to power. So if I have 10 raised to the 2 power, that's an exponential. It's equal to 100. If I have 10 raised to the 3 power, again, that's 1,000. That's an exponential. 10 raised to the 1.5 power, however, is not so obvious. So if I go 2.5, between 100 and 1,000, 2.5, you would think it might be the number exactly between 100 and 1,000. But it turns out it's not. 10 raised to the 2.5 is actually not anywhere near close to the number that's directly between 100 and 1,000. So exponentials are not so easy to predict. And it's not always easy to have a number like 316.2278 and know what number you raise 10 to get that power. And so, to get that number. So what we use is the inverse function, which is the logarithm. If I use the logarithm of the 10-base logarithm, the logarithm will tell me what number I raised 10 to get that power. So if I use the answer here, 316.227, and I take the log base 10 of it, I should get back 2.5. And I do. I get back 2.5 because that 10 raised to the 2.5 was 316, so the log base 10 of 316.2278 will be 2.5. If I take the log base 10, log 10 of 1,000,000, then 1,000,000 is 10 raised to the 6th power, so I should get 6, and I go ahead and hit that. If I do the same thing, except instead of finding the log base 10 of 1,000,000, I find the log base 10 of 1,000,000th, 1, 2, 3, 4, 5, 1,000,000th, then I get a negative number, -6, because that's 10 raised to the -6 power. However, if I take the logarithm of a negative number, -90 for example, it gives me a complex number. Logarithms of negative numbers are not very straightforward. Gives you some pretty complex mathematics. Literally, it becomes complex. So I recommend to stay away from negative numbers in your logarithmic functions. So the log is the inverse function for the exponential, the natural exponential, and the log 10 is the inverse function for 10 raised to some power. And then there are there's one more function that I want to put in here, and it's called the sine function. And essentially, you put in sine here, and you put in some variable. I'm just going to put in the number -8, and it tells me the sign of the number. If it gives an answer of -1, the sign of that number is -1. if it gives me an answer of 1, then the sign is positive. So if I do the sign, if I do sign positive 8, then I get an answer 1. It tells me that it's a positive number. This seems kind of dumb to have a function that tells you what the sign is. I can see what the sign of the number is. However, if I have a large array, for example, if I make an array of random numbers, and just putting in numbers here, I just put in some numbers, but I intersperse these numbers with some negatives, for example. And I make this array very, very big so that it's not obvious where the numbers are and if they're positive or negative, and so on. Close that array up. So I make this array and it's not necessarily obvious which numbers are positive and negative if I don't have it printed on the screen, if it's just stored over here somewhere. I can actually pick one of the elements in this array and go ahead and figure out if it's positive or negative. So I can go ahead and sign. I can find the sign of array, and I'm going to use my square brackets here, I believe is what I use, if I remember correctly. And I put in my row first, so I put in my row, I'll put in row 1, column 2, and let's see if this works. Let's see if I've got it written right. Maybe it's just parentheses, I can't remember. Use parentheses here. There we go. So when I put in the command array with parentheses 1, 2, what it does is it goes and looks for the element of the array that is in row 1, column 2. If I hit enter right now, it'll tell me what that entry is, what that element is, which is negative 25. If I put it into here, sign of array 1, 2 with parentheses, then it goes and looks at that and tells me what the sign is, which is what it did. Showed me that it was negative 1. So that can be useful when you're looking for the sign of a number in a big array and you don't want to just go hunting for it, you just want to search for it and find it. So let's take a look at So I'm actually going to look at, I've got this array that's called array now, and I'm just going to look at one more thing with this. What if I just do the sign of the entire array? This is something else that can be helpful. If I do the sign of the entire array, it gives me an array of numbers where it tells me the sign of every number in the array. So the first one in this first row, first column is positive. Second row, first column is positive. Third row, first column, negative, and so on. So it shows me the placement of all my negative numbers, which can also be useful. All right, enough of that. I'm bored with that. Let's do something interesting, hopefully. Let's take a look at rounding numbers. So I've got some numbers that I want to round off, and I'm going to say that I want to round to the nearest integer, the nearest whole number, in other words, you can think of it as. And I've got this new array of numbers. I'm just going to call them numbers. Why not? Make my array. I'm going to have 1.2, I'm going to have 7.8. I'm going to have 5.5, 0.5. And that's my array. 1.2, 7.8, 5.5, 2.3, and 8.9. And I can actually round this array just using the round function. Just round. Put in my array numbers. And it rounds each number. So the 1.2 gets rounded down because the 0.2 is less than the 6, right? So less than 0.5. So we round everything from 0.5 up and everything from 0.4 down. And it can even do multiple digits. So it can look at multiple digits. If I'm going to round, for example, 1.44449. Let's see what it does for us. And it still rounds it to 1. It looks at the 1.4 and it says this is still 1.4. Right? It looks down and rounds it to 1. Not going to round it up. Rounds it down to 1. Also, we have fix. Let's see what the difference is between fix and round. We'll look at fix in numbers. So what was numbers again? Numbers was 1.2, 7.8, 5.5, 2.3, and 8.9. It looks like the fix function rounds everything down. It rounds everything down towards 0. And what it really does is it moves it towards 0. So if I have another function called integers, or if not another function, but another array called integers, and it has some negative numbers in it. So if I have 1.2, and then I have negative 0.8, for example, in my array, and then I fix that array, then it rounds the 1.2 down towards 0, but it rounded the negative 0.8 up towards 0. So it rounds them in the direction that 0 is from their relative position to 0. Since negative 0.8 is actually closer to 0 than it is to 1, then it rounded it to 0. If I had, if I fix the number negative 8.8, then it's going to fix it to negative 8 because you're going towards 0 from negative 8.8. Then we have another one that is called ceiling, or not called floor. So if you floor a number, it takes it down towards the negative. It always rounds down no matter what. So even if I have 9.9 and I take the floor of it, it rounds it to 9. If I take the floor of negative 9.9, then it takes it to negative 10 because it rounds it down towards the negative side of the number line. And then there's another one called ceiling, which does just the opposite. It always rounds up. So if I have negative 9.9 for my number 9.9, take the ceiling, it'll always go to towards the positive end of the number line, and you're rounding up always. 9.9 will round up to 10, and so on and so forth. So lots of different types of rounding that we can use. This next one can be quite useful, and you'll use it in your homework for sure, the factorial. Right? So what is a factorial? A factorial is simply this, the factorial of 5, for example. Take the factorial of 5, it ends up being 120. That is equivalent to taking the number 5, subtracting 1, multiplying by 4, subtracting 1, multiplying by 3, subtracting 1, multiplying by 2, subtracting 1, multiplying by 1. 5 times 4 times 3 times 2 times 1 is 5 factorial, 120. It's not so easy to map out when you have a factorial of 5.5, for example. 5 times 5 times 4.5 times 3.5, and so on and so forth. But that's okay because MATLAB knows how to do this. Factorial. Well, it might know how to do it. I can't remember. Nope. So anyway, factorials we don't usually take of decimal numbers anyway. There's no real use to it. But it can do the factorial of 5. If you try to do this one, let's see what happens. Again, it doesn't know how to do negative numbers. It has to be non-negative integers to do the factorial. It does know the factorial of 1, which is pretty simple. It's just 1. And it also knows the factorial of 0, which also turns out to be 1. And that is a matter of mathematical philosophy, why the factorial of 0 is 1. We won't discuss it here. But you use the factorials to do lots of different things. For example, you can use the factorial to determine how many different things you can choose from in different situations. For example, how many different orders, how many different ways you can put cards in order. So you have 52 cards in a deck, and you want to deal out 5 cards and know how many different ways you can arrange 5 cards from a deck of 52 distinct cards. Well, the formula for that is to take the factorial of the number of cards you have, which is 52, and then you divide that by the factorial of the number of cards that you have, 52, subtract off the number of cards that you're going to deal out, which is 5. So it turns out that there are 300 million ways, 311 million ways to arrange 5 cards from a deck of 52 cards. 5 different, and it can just be 5 different cards from a deck of 52 cards. This becomes quite interesting when you are a poker player or a gambler of some kind. For example, in your homework problem, I'm going to have you do a similar problem that is not the number of ways you can arrange them, but the number of ways you can be dealt a hand. Of course, when you're dealt a hand in 5-card stud poker, it doesn't matter what order you get them in. It doesn't matter if you change the order in your hand or whatever. So the order doesn't matter. But when you're doing just a combination of 5 different cards from a stack of 52 cards, it turns out there are a lot of different ways to do that. And if you're thinking, that you're going to get a royal flush when you're playing poker, the chances of getting a royal flush are very slim. An even bigger difference, even bigger challenge is to pick the winning lottery number, because with a winning lottery number, you have like 75 different numbers to choose from, and there's 6 total numbers you're going to choose, plus there's the Powerball number or whatever it is. And all those different choices can be mapped out. You can map out the possibilities using factorials. But that number gets really big when you're talking about 75 different numbers to choose from and 6 different numbers to choose. That'll also be part of your homework. So we'll learn a little bit more about that. Let's take a factorial of a big number, 322 for example. It's showing it as infinity, and essentially what we run into here is that we picked a number that is so big that MATLAB cannot handle it. It doesn't have storage space for it. We might be able to expand MATLAB a little bit using the settings and find a number for the factorial of 322, but the factorial of 322 is a big number. 322 times 321 times 320 times 319, it adds up quick. Well, it multiplies up quick. And so we're not necessarily going to always get a number that that is going to make sense to MATLAB, or that MATLAB can handle. Now, there are 2 ways to calculate combinations. There is another function called the n-Chusek function. The n-Chusek function essentially calculates how many different ways you can get a 5-card hand from a deck of 52 cards. And all you have to do is type in 52 and 5, and you're good to go. It'll tell you right here. This turns out to be 2.5 million, almost 2.6 million different hands in a deck of cards. And there are 4 of them that are royal flushes. So you have 4 chances out of 2.5 million, 2.6 million to get that royal flush. If you're talking about the Nebraska State Lottery, I think it's 75 numbers, and you choose 6 numbers. You have 1 in, that's 1, 2, 3, 4, 5, 6, 1 in 201 million chances of picking the right number. And it doesn't even matter if you pick the same number every week. It doesn't, your chances are still 1 in 201 million if you have not bought more than 1 ticket. So to make it really worth it, you have to buy like 100 million tickets. If you buy 100 million tickets in the lottery, then you will be to the point where you have a 1 in 2 chance, a 50% chance of winning it. Well, of course, 50 million lottery tickets cost $200 million. Sorry, 100 million tickets cost $200 million. So you have to have a jackpot that's well over $500 million because that's the only way you'd get your money back. If it's not over 500 million, you're barely going to break even. So, I mean, this is an interesting question, I think, or an interesting problem. Since we just had that $1.6 billion thing, or, you know, the jackpot trophy, the jackpot in the Powerball or whatever it was. Excuse me. In Powerball, you have these 6 numbers that you have to choose, but you also have to choose 1 out of 15 or 20 Powerball numbers to get the actual grand prize. And so you actually are going to end up multiplying this again by this last Powerball number chance possibility thing. And that's going to increase this by a factor of about 20. So instead of 200 million, it's going to be 1 point something billion. It's going to be a huge number. Well, it's going to be 4 billion actually. So you're going to have 4 billion, 1 in 4 billion chance of picking the right numbers. To make it worth it, you're going to have to buy at least 2 billion tickets. I mean, to have a chance. If you bought 200 million tickets, you'd have a 1 in 10 chance of winning the lottery. But still, a 1 in 10 chance is not great. You know, and you're spending $200 million, then the jackpot, you'd have to be able to win at least, again, $500 million or $500 million. There are people that do this, but it's just not a very good bet. If you're going to play the lottery, just buy a ticket, and maybe you'll get lucky. It's just the thrill of playing the lottery, I guess, is what people like. The thrill of maybe being able to have that money, but the likelihood of it happening, very little. On average, your average lottery player wins, has a winning percentage of negative in the lottery. They lose far more than they win in their lifetime, and that includes if you put in the winners, the ones who win the grand prizes. If you put in all their winnings with all the losings that are lost, you have an average loss all the time, because that's the way they set it up. They actually know the math and they know how to make it so that you always lose the more you play. Well, essentially not the more you play, but you have always this very high chance of losing, even if somebody else wins. So anyway, let's see what else here. Let's talk about some more array functions that we can use with arrays. So I've got my two arrays in here. I've got one called array and one called numbers. I've got a couple others as well. But let's say that I want to know what is my biggest number in my array. So what is the max of array? Just type it in like that. And let's see, I don't remember what array looked like. Let's find out what array looks like. Okay, so what I do when I type in max array, it's going to give me the actual maximum number, the number that is the highest towards the positive end of the number spectrum in each column. So for the first column, it gave me 745. For the second, it gave me 45, third, 45, fifth, -9, since -9 is closer to the positive side of the number line than a -89 or -98. So that's what we get from using the max. I can also use max like this, where I take the max function of array, just like I did before, but I put it into, I can actually put it into another array. So for example, I can put it into an array of A, comma, B, comma, C, like this. And this will put all three, well, I guess I need to have, since I have 4 columns, I need to have 4 variables to put them into. So what I'm telling MATLAB to do here is I'm saying, I'm making a new array, A, B, C, D, and in this array I want you to put in the numbers that come out of this command, max array. For max array, I got out the numbers, these numbers up here, so I should get these numbers put into this new array when I hit this. I didn't like it either again. Oh, probably because I need to do this in let's do this. This has to be in columns, I think, because of the way I made my array. Nope, that's not either. Oh. Maximum array. Oh, I know what it is. I'm doing this wrong. I'm defining this wrong. So usually when I struggle with making one of these things work, I always go to help and ask my question about this function. I'll do that right now. But so let's go in here. Oh, here we go. So let's look at how we can use this. And right here, okay, so here they're using this idea where we put this into an array and it's using y and I. It returns the indexes of the maximum values in the vector I. So essentially what this is going to do is it's going to look, the index is essentially the column. So I'm gonna look for the max in a particular column using this particular function this way. So I was using it the wrong way and I thought I was doing one thing, I was actually doing another. So instead of having 4 things here, I can only have 2. And what this is going to do is it's going to put the maximum number from the second row into here. All right? So let's see if I've got this right. Nope, I still am not doing it quite right. A, B. So let's put that in there. Okay, so this is what it does. So if I put in just A, B, then it defines it. If I put in just max array, it doesn't define it. But the first number A is, or the first variable A is going to be an array of all the maximums. And the second is going to be the one where it shows us what index it's in. Essentially this tells us, if I look at my array here, it tells me what spot it's in. If I can find, where's my array? I'll just type it in here. So the 745 was in the first row, right there. 45 was in the second row here. 45 was in the first row here, so that's the first row. And then -9 was in the second row. So that's what it does. It tells you what the maximum is and what row it's in. And each column, of course, is delineated there. So now we've learned what max does in two instances. There's another instance we can use max. Yeah, so the other one that we can use is this one. If I take the max now of array, let's see. I'm trying to well, let's look at this. Let's use a new example here. I don't want to keep using the same arrays because I think it's going to confuse the heck out of me and everybody else. Okay, so if we have x equals 1, 5, 3, for example, and then we have a, oops, that's not what I want to do. Then we have a second row, it's 2, 4, and 6 in this first array. Hit enter. And then y equals another array. And this one will be 10, 2, 4, and let's say 187. Okay. So now we've got two arrays in here, and then we take the max of x comma y. This is the next thing we can, one of the next ways we can use this. What it's going to do, what it says it does, is it creates each element in the resulting matrix contains the maximum value for the corresponding positions. So what it's doing in this case is it's got two arrays now, x and y, and it's going to compare this first row, first column with this first row, first column, and then put that number, put the bigger number in here. So 10 was bigger than 1. We put in 10 here. In the first row, second column, however, 5 is bigger than 2. So in the max array, it puts in the 5. So you can do this with two arrays that are the same size, but they do need to be the same size. And if they're not the same size, it will return an error. So get two arrays that are the same size, and then it will compare the arrays. It'll build a new array with the maximums in each. Now, if that's not all enough for you, there's another function called min that does the same exact things, except it finds the minimums. So you can do all the same stuff that you did with the maximum function using the minimum function. Again, I want to remind you of something. Let's say that I wanted to do this, but I wanted to turn these arrays into, instead of 3 rows, or 2 rows, 3 columns, I want to turn them into 3 rows, 2 columns. I just type X and I put the apostrophe here, and I hit return, and it will flip that array on its end. It essentially makes all the rows into columns, the columns into rows, and now X, which was 2 rows and 3 columns, is now 2 columns, 3 rows. Stands it on its end. So you can do that. But still, this column, this X, X prime or X apostrophe matrix or array is not the same size as this one, because this one is 3 rows, 2 columns. This one is 2 rows, 3 columns. It has to have the same number of rows and the same number of columns to be same size array or same size matrix. Okay, so that is the minimum maximum. Those are the min and max functions. Let's talk about mean, median, and mode. The mean of a function, or the mean of a group of numbers, essentially the average. And so if I have the mean of x, what it's going to do is it's going to take the average of x, the x array, add all those numbers together and divide by how many numbers are in there. But it does it by, in this case, it's doing it by rows. So we're adding 1 plus 2, and we're getting an average of 3. 1 plus 2 is 3 divided by 2. Then 5 plus 4 divided by 2 is 9. And then 3 plus 6 divided by 2 is 5 plus 4 divided by 2 is 9 divided by 2, which is 4.5. Same with 3.6, it's 9 divided by 2, which is 4.5. So it's essentially going to give you the mean of each row if you just type in the array. For the median is similar to average. But it's not actually giving it to me. Why is it not giving it to me? Did I type it in wrong? So for some reason it changed my function. Changed my array x. If I go to my y array though, if I use the median of the y array, and I just type in the y array to compare here, I'm not liking that either. Oh, that's because, I see what I did wrong. Okay, so anyway, the median is similar to the average, like I was mentioning before, except that what it's going to do is it's going to find the number that is essentially exactly in the middle in any particular row. Since we don't have a number that's in the middle, we have just 10 and 1, and there's no number in between them, it's giving me this, these funny answers. However, if I make a new array, if I call my new array M, and we have then 2, 4, 78, for example. If I have that array, hit that, and then I take the median of M, then it's just going to take the number that's in between the two outside numbers, the one that's always in the very middle. If it doesn't have one that's in the middle, if you have an even number, so if I say N equals an array of 1, 2, 3, 4, for example, and I take the median of that, then what it does is it goes to the middle two numbers, the two that are sharing the middle, and it takes the average between them, which is 2.5, which is why I got the 5.5 up here and the 1.5 here. So if you have an odd number of numbers in your rows or columns, then it will actually look for the one that's just sitting in the middle. And if it doesn't have an odd number, it takes the two that are sitting in the middle and averages them. Now the mode is a different thing entirely, once again. So let's make a new array. We'll call it popular. Put in some random numbers. We get a bunch of random numbers in there. They're not entirely random, but it's an array that's pretty big. And I want to know the mode of this particular thing, which I called popular. All right. So what's the mode of popular? It returns the answer 4, and that's because when I was entering in these numbers, I deliberately typed 4 several times. So 4 shows up in this array 1, 2, 3, 4, 5 different times as a single number 4. In other words, it is the most popular number in there. And mode in French literally means popular. And so you're looking for the most popular number, the most repeated number. That's what mode is. So now we've got a whole bunch of functions under our belt. Let's actually do a couple more just for kicks, and then we'll come back and do our final functions. Let's do a couple more that are kind of mathematical. For example, I've got my popular function. I've got this, my popular array. I've got this thing called sum. I can take the sum of popular, and it'll actually add up all of the different elements in the array popular. I can do prod of popular. And it'll take the product of all those numbers. Right? And then there's one. There's one called cumulative sum, and this one I'm not sure about. Let's take a look at let's look at the cumulative sum. Cumulative sum of one of our earlier arrays, x, that's a little simpler. And then let's look at x and see what it does here. Like I've said before, it's been a while since I've gone through all this stuff in MATLAB, so I have to remember some of it. So our original array is 1, 2, 5, 4, 3, 6, right? Or 1, 5, 3, 2, 4, 6. They're doing the cumulative sum. I think what they're doing is they're giving us the first number in each column, and then they're adding all the numbers in the column and giving us that number. So 1 is the first number, and then if you add 1 plus 2, you get 3, right? And then 5, and 5 plus 4 is 9. 3, and 3 plus 6 is 9. So that's what they're doing there with the cumulative sum. And the cumulative product does a very similar thing. So if I use cumulative product instead of cumulative sum, prod like this, then I get 1 times 2 is 2, 5 times 4 is 20, and 3 times 6 is 18. And that can be really, really useful for doing lots and lots of calculations. Very similar to functions you can use in Microsoft Excel, for example. So those are the last three functions, mathematical functions I want to talk about. And we are going to get into some data analysis functions next. And then we're going to learn how to enter in some certain types of numbers, and we'll be done. We'll take a little bit of a break, go get a drink, and I'll be back here in about 10 minutes past the hour. I'm going to just keep recording here so that we have this recorded for sure. I think I'm recording, so I hope I am. So, anyway, that's where we're at this point. Make sure that you're getting all this stuff down as you're watching this video or participating online or wherever you are. Make sure you're getting all this down in your M file for this week. It should be called your name. My name is Jared Daly, of course. Then underscore week 3. Put that on your computer and enter this stuff into your MATLAB stuff that I've already included on this video so that you can see how it all works. I'll see you in 10 minutes or so. All right. Throat's drying out a bit. Okay, so we're getting through it here. Some more functions to learn, how to make MATLAB do things, and hopefully as we're learning more and more of these functions, you're realizing that you can start to use this big old machine we call MATLAB to do homework. Hopefully you can get an idea of that. Anyway, let's take a look at let's look at some functions for arranging data and manipulating data. So we're going to start with an array. I'm going to go ahead and clear out this mess. So I've cleared off my workspace over here. I've cleared out my window. And now I want to start with a new array. Let's do let's just do a simple one. So we have x equals, build an array, just some numbers, and that's fine. So there's my array. 1, 3, 5, 6, 3, 4, 2, 5, 2, 1. We have a function called sort. So if I sort x, let's see what happens. It's going to sort it from smallest to biggest, essentially. And it does integers as well. So if I use an integer, if I call an array of integers here, and do a -2, 4, -8, 89, whatever I'm going to do here, it recognizes integers as well, and I can sort that. Let's see what happens. You can see that it goes from the most negative number on up, and if you have repeating numbers, it just puts them together. Goes through 0 and up to the most positive number. So it knows how to deal with negative numbers as well. So that's the sort function. And we can actually choose it to sort in a different order. So we can actually choose it to sort, for example, in descending order. To do that, we do choose sort, or whatever thing we're trying to sort, and we just type in quote descend, and then close quote. And that will tell the sort function to sort in the opposite order. Pretty straightforward. If we build a matrix, we'll call it matrix or not. So we build a matrix called matrix, and we do, I'm going to use a different format this time, just so we do use different formats, we learn to use different formats. Remember that the space puts us in a new column, and the semicolon puts us in a new row. Right, so I'm making a bunch of rows here. Hopefully I've got that right. How many do I have? 1, 2, 3, 4, 5. Looks like we've got 5 here. Let's hit enter. 5 rows, and I've got 2 columns, right? So if I go ahead and sort this, let's see what happens. Sort x. Nope, that's not what I'm going to do. Sort matrix. There we go. Okay, sort my matrix. You can see that it does sort the matrix, and it does it by column. So it sorts each column in the matrix. If you don't want it to sort columns, you want it to do the opposite, then you have to use a new function called sort rows. And then type it in, matrix. So it's a completely different function. It'll sort the rows, and let's see if what's my matrix. So it sorted them in let's see, sorted the rows 1 to 3, and then where is mine? Is that my matrix? This is my matrix. So it sorted 1 and 3, did 1 first, which it should have done, and then it did, oh, in this case what it does is it sorts the first, so sort rows actually sorts the rows so that your first row, your row that has the smallest number comes in first. So that was this row. Then your row has the second number in the first place goes second. So it's actually sorted the entire row in here. So this one was first, and then the row 3, 1 came in second, and then the row 5, 5. And it goes by the first element in each row. And then you can do it based on the second column as well. So if I sort rows, and I want to sort by the rows of matrix, and then I can actually choose the second row or the second column to sort by. So if I choose the second column to sort by, I just put in a 2 there, and it's now sorting by the second column. So you can see the second column has all the numbers sorted. So it's just a different way of sorting numbers, and that can be extremely useful if you're bringing in a big chunk of numbers and you want to arrange them in ascending, descending order by some way, or a set of rows or columns you want to arrange that way. It can be very helpful. So, how would we use this? Here's an example. Let's say we have some scores from some kind of a contest, and we bring them in. And remember, in MATLAB, we often import things in, and we will be doing that in this homework this week. The homework will include a file that you will have to download to your computer, and then you will learn to use these commands and these functions to sort through it. But let's say that we have this matrix of results from a contest where my first contestant got a score of 23, my second contestant got a score of 45, my third contestant got a score of 67, my fourth contestant got a score of 34, my fifth contestant got a score of 28, 26 maybe, and so on. So you've got however many scores in there, and those are my results. And I want to know who came in first place. So I can go ahead and sort these things according to the rows. So I sort the rows, but I'm going to sort them by the second column. Right? Sort rows of results by second column. And I can see that my first player got the lowest score, my fifth player got the second lowest score, and so on. But what if I want to know who got the highest score? Then I would go ahead and do sort rows. And I think that I can do this, so we're going to try it. Results by column 2, and then I'm going to do descend. Close that. Close this. Oops, doesn't like that. So let's do it this way then. So if I sort results by column 2 again, and I get these, then I have a new matrix here called answer, right? I don't know if I can do that with the sort rows. I'd have to probably split them up into two different things, and then I could do it. And that's possible. So for example, if I take my answer here, and I take the first column, So answer 1, first column here. No. Answer. Okay. Well, we'll get to that. I'm going to have to introduce you to some new stuff before we get into actually pulling apart arrays. I don't want to pull apart an array right now because if I do, it'll confuse you. Hopefully you're not too confused already. But anyway, that's sorting. You can sort those things and we'll just leave it at that for now. What we really want to do next here is to go on to our next thing here. I want to use a new function called size. So let's do size of results, for example, and see what that gives me. So size is going to return some numbers, an array of numbers, and essentially the first array is going to be the first dimension of the thing that you put into your size function. So we put in the array results, and the results array essentially is this array of 5 rows, 2 columns. And so the first thing is the rows, the first dimension, 5. The second one is the second dimension, columns, 2. So 5, 2. This is a 5 by 2. If you have a really big group of numbers, this can be quite useful. You don't know how many, somebody's giving you this file to upload into MATLAB, you don't have any clue how many entries there are. You can put it in size and it'll tell you exactly how many entries there are. It can also be helpful in finding things. So if you're trying to find a particular thing within it and you know that it's the 50th number in the array, or if it's the halfway point in the array, for example, you can find the size of the array, and if the array is 100, then you know you're going to type in 50 or 51 for that. So size is very useful. You can also assign these two numbers, 5 and 2, to variables, doing like we did before, where we have a comma b here. We're just going to say that the numbers 5 and 2 are going to now be given values. So I take the size of results here, and now a is equal to 5 and b is equal to 2. If I type in the number a, it tells me that it's 5 for 5 rows. So you can do that as well. And then there's another one that is going to calculate the length. So if you have the length of results, let's see what that gives for us. It gives us answer of 5. So the length, when you type in length for an array, it's actually going to tell you the number of columns or the number of rows in it, or the number of entries that are just entered in. It's not going to tell you how many columns are in it, just the number of rows. So it gives you a little bit less information, but it's also useful when you're trying to figure out, it's very useful when you've got a very long array again, but also it's very useful when you have an array of letters. So if you have a bunch of letters that you've entered in somewhere into a script of what do we use? I'm trying to remember the term we told you guys last time, or a couple times ago for that. But when you're actually typing in words, the length of those words will come back. So let's actually do that really quick. Let's type in a word. Let's say that A is going to be equal to, strings is what we call it. So we call it string. Put it in quotes here. And so now the variable A is now the word string. And the reason we call them strings is because each one of these letters is represented by a number. And so, but the computer recognizes those numbers when I put them in quotes as letters, and it types them out as letters. But I can also, this also has a length. So if I type the length of A in here, it will actually tell me how many letters are in the string A, which is string 1, 2, 3, 4, 5, 6, right? So it's 6 in there. So if I have this really long string of letters, and I've typed in a bunch of stuff, and I don't want to go through and count them. So if I'm typing in a bunch of letters, and even spaces and and other things like exclamation points, whatever else, they'll all come in as things in this string. I have this long string of things I've entered into MATLAB. It knows what it is, but I don't know what the length of it is. I can go ahead and type in the length of long string, and it'll tell me that there's 36 in there. 36 characters in there. And that includes spaces and any kind of punctuation you put in there. And again, something else that can be quite useful. If I have a matrix and I use this one, it's going to be numal, which is number elements, so num elements, numl. And I use, what is my matrix up here called? Results, for example. This will just tell me the total number of elements that are in the matrix element, results. So it just has 10, so it returns number 10. All right, now, I think I can download I'm looking for a file name really quick. No, that's not right. I'm going to download a file here really quick. Let me see if I can find it. Open. Go to my MATLAB desktop. I'm not entirely sure it's going to let me get that file. All right, well, I'm actually going to just search for one. I'd probably find it easier, find it faster and easier, instead of trying to figure out how to get to it from my computer, since my computer is not always connected here for some reason. I'm going to go to MATLAB data file here. Let's see if I can just find a MATLAB data file that we can upload. That's an image. I actually want a data file. Yeah, okay. I have to figure out why this computer's not connecting to the network, so I can get those files. Let's actually go to Blackboard really quick. I'm going to open up Blackboard, and we'll show you what's it will be kind of what you're going to see here. So if you get into Blackboard and sign in with your name and password and all of that. Apparently doesn't like my password. Oh, goodness, you gotta be kidding me. Oh. There we go. And I'm going to go into my class here. I'm going to a place that you don't have for when you get in here, because we're going to look at some things that you don't have. All right, so you're going to come across files in fact, in your next homework assignment, you're going to come across a file that looks like this, thermocouple.dat. And you go ahead and click on it, and you're going to save that file to your computer. And then you're going to go ahead and go to MATLAB and open that file. So if you go to the open, the little open button up here, and then I'm going to go to my downloads and find thermocouple, which hopefully will be in here. There it is, thermocouple.dat. It's not letting me map files. There we go. Nope. I'm just going to let it do all files, and I'm just going to open up thermocouple.dat. It's going to open up a file that is essentially just an array. We've got 3 columns in this array, and a whole bunch of rows, 13 rows, and all this data in here. And so we can go ahead and we can bring that into into MATLAB. It's actually giving us an option to go ahead and import this in. We can import it as column vectors or a numeric matrix or a cell array or a table or whatever we want. I'm going to just go ahead and bring it in as a numeric matrix, and I'll import it. And now it should be in MATLAB. So it's right here, thermocouple. And I can open it up. It's a 13 by 3 double matrix. And it's good to go. If I open it up in my workspace, you can see the numbers here. Now, I should be able to import this in. Let's just go ahead and type in thermocouple and see what it gets. This is all caps. Let me go ahead and put it in there. If I just type it in, it just brings it in as an array right into MATLAB because it's in my workspace here. It brought it into my workspace. I can also bring it in as a mat.mat file into here, into my current folder, and then I can load it into MATLAB. But in this case now I've got this array of numbers and I don't really know much about it. It's a whole bunch of numbers. I can start to work with it then. Start using some of these functions that I've used. So for example, if I wanted to, what are some of the things we've learned so far? I want to find the maximum in thermocouple, right? The return. It doesn't like that because I did all lowercase, and this file is actually, or this thing is actually case sensitive, so it changes it for me. And it's going to find me the maximum number. 87.1 turns out to be the maximum number in column 1. 90.44 is the maximum in column 2. And 89.0 is the maximum in column 3. We've now found the 3 maximums, and we know that the absolute maximum in this file is 90.4. That was the maximum. If this was temperatures, which it probably is for a thermocouple, we found the maximum temperature. And let's say that we wanted to find the sum of thermocouple. All right? What does that do for me? Well, it adds up the three different columns. So this is the sum of all the temperatures, or the sum of all whatever the numbers these are going to be. Maybe these are counts that we counted the number of chickens in the chicken coop or something, and this is for the week or for the year or whatever else. So just add them up. So whatever it is, you can do these kinds of things using these functions. Once you've got a big file in there, it can handle them no problem. We can also use the size and the length and all those other functions, just like before. Okay, so I think that takes us to the point where we want to start something slightly different, which I've actually shown you before a little bit. I'm just checking the list of functions, make sure we've covered them all. There's a few more math functions that we'll cover here at the end that I missed. But let's take a look at one other function called the random function. And we've talked about this before, I think. The random number function. If I just type in random, it just gives me a random number between 0 and 1. And if I wanted to make a random number that is different than that, then I take random times 10, for example, will give me a number between 0 and 10. Just randomly. If I type in that command again, it gives me a different number between 0 and 10. Just keep doing it, it'll keep doing it, keep doing it, keep doing it. Why could this be useful? Well, this can be useful because it can actually create, you can actually create arrays of random numbers to use for whatever reason. There's a lot of reasons to use random numbers. So if I say random 2, comma 2, for example, it'll create an array of random numbers that is 2 by 2, 2 rows, 2 columns. And if I want to create an array of random numbers that is 9 by 9, I can do 9 by 9, and then I can actually multiply that by 100 and have an array of numbers now that are between 0 and 100 that are completely random. A 9 by 9 array. You can see it becomes quite big. And if I assign that to something, let's call this nines, for example. I create a random array that is 9 by 9 that is called nines, and it is now in my workspace here. If I click on it, it's a 9 by 9 double array of random numbers between 0 and 100. You can see here one that's close to 0, and here one that's closer to 100. And everything in between, all kinds of random numbers. Random number generators turn out to be very useful in science and engineering. They help us to build models of things that behave like nature, because nature behaves quite randomly. If you want to do a 9 by 9 array, any kind of n by n array, so 9 by 9, 10 by 10, whatever. They've actually cut me off. Why did they cut me off? I don't know. They cut me off. Well, somebody cut me off. Well, whatever. I'm still recording on my computer here, so it still works. I assume it still works. Whatever. Go away. I don't have time for you. Yeah, my recording on this computer is still working, so we'll go with that, and hopefully, let me just check to make sure. Yeah, my microphone's working, so that's good. Okay, my recording is still going, so let's not worry about what Zoom is saying. But someone's trying to connect to me. Hello? Let's just get away from that. So anyway, if you want to create a random n by n array, random n will help you do that. So we just want a random array, and we just pick the size of it. So I want to do 9 by 9, I just do 9. If I want to do 10 by 10, I just do 10. If I want to do a million times a million, I do a million, whatever. So do 5, for example. Creates, oops, random 5 array. So this gives me a 5 by 5 array of random numbers. And notice that it's actually giving me negative numbers as well. See right here. And you can do the same thing with an m by n matrix if you just do a comma. So random n, do a comma 7, for example, to give you a 5 by 7 array of random numbers. So that is the random function that we use quite often. Now, for the very last few minutes that we're going to be working today, and we're not going to do much more than that, we'll be done with our study of functions after this, built-in functions anyway. We'll learn more functions as we move through MATLAB, but these are kind of the basic functions we use for math and for matrix manipulation. But I do have a few that I'd like to cover here right before we leave, just to give you some experience with them. For example, if you have a number 546 and you want to find all the prime factors of 546, you go ahead and put that number in there and it'll factor it out to all its prime factors. So again, this is something you can use for your homework quite a bit. If you're trying to factorize a number, there you go. Greatest common denominator, we can do that too. Greatest common denominator. MATLAB can find the greatest common denominator between two numbers, 786 and 468 or something like this. No, let's do 46. The answer is 2. That's the greatest common denominator between those two. Let's do another one with some bigger numbers, 466. Still 2. Let's find one that has a greater common denominator, 468. Oops. 6, yeah, so there we go. We have two numbers that have a greater common denominator than 2. Factor, greatest common denominator, help you already know. Let's make sure we get all these here. Here's an interesting one. This was recently in the news. Somebody discovered a new prime number. If you want to know if a number is a prime number, type it into the isPrime function, and it'll go through a series of calculations to try to divide it by numbers and see if it is divisible by anything but 1 and itself. And so you just go ahead and put that in there. And if it returns the number 0, then that is not a prime number. If it returns the number 1, then it is a prime number. So apparently the number 57,893 is divisible by some number divided besides itself and 1. It's not a prime number. If you type in, instead of isPrimes, just primes, it will actually find all the prime numbers that are less than that number. So here are all the prime numbers that are less than 5,000 or 50, whatever. Quite a few prime numbers actually. Where'd it go? There we go. 57,893. So I found a lot of numbers, it turns out. that are less than that number that are all prime numbers. I think we've covered everything. There is one more thing that I think is it's new to me anyway, that we should mention. We talked earlier about how you can use MATLAB to do some trigonometry, and that it uses, for its input, it's using radians instead of degrees. But if you just put a d on the end of the sign, it can actually calculate in degrees as well. So sine d of 360 should be 0, and it is. And cosine d of 0 should be 1, and it is. So you can just put a d on the end of your trigonometric functions and it will calculate in degrees as well, which is new to me. I didn't know that it does that. The more you use MATLAB, I guarantee you, the more and more you will learn what it can do. It does so much, so much, so much. Even professional users of MATLAB, even people that work for the company MathWorks, discover new things that it does, because the people that work for MATLAB are not the people that wrote MATLAB. MATLAB was written a long time before they got there, and it's been added to and enhanced and changed and improved and everything else. So, those are the last few functions that I want you to learn today. I will have a homework assignment posted. It's about halfway finished, so I'll have that done by the end of the day today. And you can get in and get started on that. Make sure that your first M file in the homework assignment is the M file that you get from watching this video and doing all the activities we did today. And feel free to play around with things. If you find something that you want to explore the capabilities of, go ahead and do that. Even though this lecture is a little bit shorter today, don't assume that the homework will be shorter, because applying these things is a lot more involved than just talking about them. So we will have several parts of this assignment will be things where you will be creating or downloading or doing some kind of array work where you're finding a maximum, looking for the maximum row, or sorting things out and doing some calculations with that, using all of these functions that we've talked about today. So do not assume that it's just going to be quick because the lecture was kind of short. There's a lot that can be done with this. Next week we will get into manipulating arrays in greater detail and creating arrays in greater detail, bigger arrays, more arrays, and then we get into plotting, actually making imagery with MATLAB, and I think that students find that much more interesting. And a big reason for that is because you actually get to see something happen instead of just numbers on the screen, right? We're going to actually make some animations by the end of it. And it'll take us a little bit longer to get through that stuff, so it's a couple weeks off, but we'll start taking a little more time, maybe a couple of weeks on one subject, and but we will be getting closer and closer to making programs that actually do something rather than just math and more math and more math. So, any questions at all before we're done today? Looks like we're good to go. I'm going to go ahead and stop all of our recordings here. And we will be done for today. So have a great week. Make sure to check up on the homework and get started on it.